know we've provided key insights and perspectives from our speakers today, and we look forward to your insights and questions as well later on. Our first speaker this morning is Kieran Kennedy, President of the Association of Consulting Engineers of Ireland for 2018-2019. Kieran is a chartered engineer and has served on the ACI Executive Board in a number of roles previously. He's also a former chair of the ACI Structures Committee and has maintained an active involvement in that over the years. Kieran graduated from Bolton Street with an honours degree in structural engineering and began his career as a design engineer in a site-based role, gaining particular experience in refurbishment and the interaction of new build with heritage buildings. In early 2016, he was appointed Managing Director of Barrett Mahoney Consulting Engineers, which is an award-winning civil and structural engineering consultancy with offices in Dublin and London. Previously, Kieran held roles of Project Engineer and Project Director in Barrett Mahoney. I'm delighted to welcome Kieran this morning to talk about recent practical experience and developments concerning open BIM standards. Thank you.
Thank you very much, Sarah. I'm delighted to be here this morning on behalf of the ACI and of our members. I'm very pleased to be invited here as part of the CitA series of presentations that we're hosting today's event. I hope to give you some context of an Irish perspective in relation to where things are at in the world of BIM. I've leaned on the mouse here on my slide, I've gone a little bit forward. As Sarah introduced me, my name is Kieran Kennedy, President of the ACI and Managing Director of Barrett Mahoney Consulting Engineers. And as a member of the ACI, we're involved in the Structures Committee. We've got a very active BIM committee in the ACI, which covers all disciplines across the built environment. I'm sure that people who have attended these events before have met several of our colleagues who have been involved in the presentation of previous CitA presentations, particularly Brian Hiff has been heavily involved. Be a common face that you would have met at these previous functions. There's lots of cross-pollination between the BIM Committee, Bolton Engineers Ireland, the ACI, and our counterparts in other organisations. In addition to the work of the BIM Committee, the Structures Committee also has a dedicated Structures BIM task force, which has been set up to review the work of those involved in BIM. Needless to say that the members of the Structures Committee tend to be the managing directors and directors of different organisations, and it was only thought proper that their counterparts who are more at the cutting edge of BIM and the implementation of standards have a voice at the table. And for this reason, a particular task force was set up. It's been very interesting to see the debate that this has brought about and to get the feedback from people that are using BIM on a day-to-day basis and be able to feed that back into our meetings. In our own organisation, we have a very well developed BIM capacity, and we started the implementation of BIM probably in earnest, would be fair to say, about 6 years ago. We had dabbled with it before that, but it's built up over the last 6 years or so to a more stronger and certainly far more integrated design tool. And at present, with a staff of approximately 90 members, we'd have 20 people or so that are well tooled up using BIM capability on a day-to-day basis. This is a composite image of a couple of our projects that we've done over the last while, just pieced together to show the scale of work that we've been involved with on the BIM stage. At present, a significant number of our projects would utilise BIM at different levels of applicability. I think that's really where things are at, trying to determine the level of applicability and the level of, not only level of detail, but the execution standards that need to be adhered to. The implementation, in our opinion, of BIM, full and proper BIM, is probably behind where we'd all like to see it being at. And I think this has been a topic of plenty of debate, and I'm sure it's something that will be arise later on in our proceedings today. The landscape is changing, there's no doubt about that. The lines that developed when we began to use maybe CAD back in the 1980s, where engineers and technicians had differing roles, and has been disrupted over the last while and are less defined. Engineers are now far more involved in the model generation and than they would have been in the 2D task. The skill set of engineers needs to be developed to embrace this technology and to process it. And in our opinion, in our organisation, we're seeing far more involvement of graduate engineers adopting BIM and being able to work and design using that tool, and most importantly in relation to both design and detail and full BIM implementation, working with other members of the design team, but also in relation to analysis and the ability to translate building models over to an analysis tool. An understanding of the implications and resources necessary for proper BIM implementation needs to be appreciated by all stakeholders, and in particular clients. It's appreciated that there are enormous benefits to be offered by the use of BIM. And a well-orchestrated BIM project will outlast the construction stage and bring immense value to the client, both at construction stage and also at building use and ongoing maintenance. And for this reason, it needs to be funded by the client. They have an obvious and important role to play in that regard. We've seen time and time again where consultants, and we're probably to blame ourselves, will launch into the execution of a BIM project without fully appreciating exactly what needs to be done and what resources need to be applied to it. But in order for it to be done correctly, it needs to be resourced properly. It needs to start off in the right foot, and again, that's where standardisation comes into play, in that when people start a project, if they are to start into that without the proper standardisations and common goal, the results will be satisfactory. When we first started out using BIM, we quickly found that we had issues in relation to standardisation across the office. As our input began to develop and move on into wider fields and across other practices, it became very obvious that the standardisation throughout the different practices was becoming an issue, and that there was far too many standards out there. People were not necessarily following the same families, the same routes, the same file setups and drafting approaches. And as we've gone further afield and explored international markets, we've again found that this is more and more important, being able to deal with our international counterparts and to be able to deliver a properly executed BIM project outside of our own more comfortable neighbourhood, let's say. Let's look through a couple of slides here of a few different projects that we've done utilising BIM, particularly in relation to conservation projects, which have their own challenges in relation to design, development and detail, and also from an analysis viewpoint. The interaction of the old and new structure, again, is something that needs to be properly developed, and again, standardisation in those particular areas can be a little bit difficult to achieve, given human nature and the want and desire of people to draw things and to develop designs based on how they see it. I'm running tight on time, so again, a few demonstrations on current BIM applications. A snapshot of our current involvement on certain projects. In relation to civil elements, just to note that again, standardisation across the civil side is something that definitely needs to be looked at. We've all developed our standardisation systems in relation to buildings, but we feel that on the civil construction, on the civil side outside of buildings, there's more challenges in that particular area. Big advantage of the implementation of the standard systems and the model is in the analysis software that we've found, particularly across different design houses and software providers. Certainly with the open source and changes in the approach, we're no longer really reliant upon having one element of software from one company or one design or software developer. It's certainly proven that we were able to change between different software providers, which is a great advantage, I think, and has hoped and has helped us to some extent to allow for software competition to develop. and to allow for our design systems to move from one type to another. And certainly the crossover between different softwares and let's say the developing a model in one particular software and translating that over to analysis in an analysis software package from a different developer has proven to be more and more seamless as we've gone on. Certainly in the earlier days we found that it was actually quite inflexibility in relation to trying to transfer a model over into a different type of system. And I don't want to get into the names of different software providers, but certainly it's proven to be far more successful lately. And it's one of the advantages, I think, of the open source and the development of over the last while. But again, standards have an important part to play in that, and in particular when it comes to detailing our own models, that if we don't start off on the right foot and develop our model appropriately with the right eye on detail, we find that it is not so easy to bring into the model later on, and it involves people building a separate model for analysis, which is a waste of time and completely defeats the purpose of developing the BIM model in the first place. So I hope that we'll see some informative discussion here today. Well, I know there'll be some good points to be made in those particular areas, and look forward to see what's been presented by our following speakers, and to be here today with a much better understanding and knowledge of where things are at and where the future of BIM lies, and we look forward to applying it day to day in our practice. Thank you very much.
Thank you very much, Kieran. It's very encouraging to hear that graduate engineers are coming into practices with either a knowledge of BIM already or very willing to be trained in it in the use of design, but also in standards as well. And I totally agree that it's very important to, as Kieran says, start off on the right foot to get it right from the start as much as possible. I'm delighted now to introduce Geraldine Larkin. Geraldine is the CEO of the National Standards Authority of Ireland and was appointed there in February 2017. She's a highly experienced senior executive, having previously held the positions of CEO for the Irish Greyhound Board, a commercial semi-state company. She was also the founding CEO of the Private Security Authority in Ireland, a regulatory authority charged with the licensing of Irish private security industry. And during that time, she utilised existing voluntary standards as a mandatory part of the regulatory regime, and also worked with industry stakeholders. Previously, Geraldine undertook a variety of senior roles in the Department of Justice, Equality and Law Reform. She has an MBA in Technology Management and a BA in Public Administration. She was also elected as member of the Senelec Administrative Board in November 2017. I'm delighted to welcome Geraldine this morning to talk about standards as an enabler to transition. Thank you.
Well, good morning, everybody, and well, that's it, yes. And I'm delighted to be here this morning. As much to learn from you as anything else. And this morning's event is a real example of the collision of technology with what has been a very traditional sector. And it's probably no different to many of the other sectors that we're experiencing. Yours is a unique opportunity, giving the potential for growth and development. And what I wanted to do this morning was give you a little bit of information about the NSAI, talk to you in terms of the linkages as I see it, particularly between standards and BIM. And I know Kieran has alluded to some of that this morning, so it's really to expand upon that. And then to broaden the landscape, take you to Europe, give you an indication of what's happening at a very, very high level, and then finally reflect back what's happening in Ireland and close out with what our plans are under the roadmap. So to start off, the NSAI, our government body, statutory agency of the Department of Business Enterprise and Innovation, and we have a number of roles, and so primarily our roles all revolve around standards. We're the authority charged with developing standards, and equally we're charged with certifying those same standards, providing you and other interested stakeholders with information on the benefits of standards, the use of standards, and indeed technical information that might support the decisions that you make in and around about the use of those same standards. So our world is one of ensuring that we have balanced stakeholder representation, that we take the views of everybody in this room, that we are able then in that environment to reach a consensus on what the Irish nationalist position should be on a wide variety of different matters. So oftentimes our discussions are quite technical, they're quite specific, but that's not to undermine the huge importance of those areas for us going forward. Equally, the formats that we employ and deploy allow and ensure that everybody in this room has a chance to make a difference and to comment on our work, and also to be advised simultaneously of what's happening at European level. We're very fortunate that Ralph Montague here is chairing the Irish BIM Committee, and I'll come back to that at a later stage, but just to say that there is very real and active connections between this room and the work of the NSAI and standards. And if I look to the roadmap, and specifically in terms of how the roadmap calls out standards and what has been described. So the roadmap very significantly describes BIM, the relationship between BIM and standards, as a common agreement between all the built environment stakeholders and how to describe the elements of buildings or infrastructure, from the macro down to individual building products. So the standards work that we're dealing with will deal with everything from the macro to the micro. And that's where the challenges for us are. How do we keep engaged at all levels of this process, and how do we ensure that what happens at a micro level is translated up to the big macro projects that Ciara displayed just a couple of moments ago. But it's hugely important that we do that, because if we don't, we won't have the interoperability as between different systems. And we can do all of this work, but it's wasted, it creates duplication if at the end of the day we can't transfer the knowledge from one system to another. And I know many in this room are already engaged in various aspects of BIM. So for us, looking to the future and looking to the future of where Ireland can play a role, the key to this is ensuring long-term certainty, such that the investments that you are making today will have a longevity of life into the future, so that you can be sure that what you're doing today will translate repeatedly, time and time again, going forward. Equally, I'm looking beyond this room, and I'm looking to the future users of the various built assets that you are creating. And we need to ensure that those folk are also engaged and know and appreciate the potential that the systems that you're developing can provide to them. They need to know how they can use their software to manipulate what you've done to their best advantage to maximise efficiency. And I'm looking at the longevity of the projects and the work that's being done here and around them, supporting projects during the entire life cycle of various built assets. And I suppose the bottom line there is this work future-proofs what we're all at today. And this is why BIM standards are so important for us all going forward. And much has been said about BIM standards, but what actually do BIM standards cover? And I'm not going to go into the detail of the standards, and I'm sure people in this room are far more expert on the detail of the technologies. But in the broadest sense, BIM standards cover production, management, and exchange of architectural, engineering, construction, and operation information regarding the built environment. So effectively, BIM standards cover every aspect, and any aspect that you might consider of the work that you're doing. And they need to do that, because in order for us to be sure that we have certainty into the future, that the BIM scope for standards needs to be as broad as possible. So I see BIM being relevant to planning, design, construction, but crucially also to the subsequent operation of every asset, such that we have, as I said, mentioned, this reliable basis for decision making. And there is no doubt about it that the standards developers see the solution to the management of information be critical as its reliance on BIM. And not alone that, but then go back to what I said, BIM relies on the application of common standards, such that we can ensure that exchange of information throughout different projects, throughout different stakeholders, and different users, and different external users who might never be involved with the design and construction of the built asset. So that then is where I see the connection between BIM and standards. Looking then to, well, where actually do standards come from? And just to take it back for just a minute and give you an idea of how we manage and where we fit into the picture. So we're the National Standards Authority of Ireland. So that gives us 3 roles. So in terms of standards development. So firstly, we develop standards nationally. We develop standards with our colleagues in Europe, and we also develop standards at international level. So CEN and CENELEC, they're the European fora, and ISO and IEC, the international fora. And we act as a conduit by bringing together national experts, getting their views, and then once we have those views, either transferring those views ourselves or indeed affording national delegates the opportunity to come forward and represent Ireland at various international committees. So all these standards, as I mentioned, they're drafted from consensus. Typically, standards are not mandatory, although on occasion standards have been included in legislation. But really, where standards come to the fore is when there is a commercial advantage, such as in the BIM environment, that consensus agreed documents give competitive advantage going forward. So that's the key work we're achieving, and we're striving to achieve for the state body. We're striving to achieve consensus to reflect Irish national perspectives, to bring that forward at European and international level, and equally then to reflect back what is happening at an international level or at European level, so that we are acting as that conduit for you, such that you're aware of what is going on. And I suppose for me, one of the key criteria concerned at this point in time is that some of the standards work, it's not the most exciting. I can't show flashy videos of the work that we're doing, but that's not to undermine the importance of the work. And one of my fears would be that because at the moment the work is quite technically focused in terms of IT, that the standards that will be set for this sector will be set by IT specialists rather than professionals such as yourselves. And I think we need to be very mindful of that, and we need to work collectively to ensure that we get through the Mirror Committee, through RALPH, that we get that exchange of information, and that you're all aware of what's happening in the various committees. And I suppose looking specifically at standards in Europe, there's a key working group in Europe, and it's the CEN TC 442 committee. It was established in April of 2015. It's chaired by Norway, and it has quite a significant following and interest. So we have strong input from the Nordics, so from Norway, Finland, France, Austria, Spain, UK, Germany, Denmark, Portugal, Slovenia, Italy, Ireland, ourselves, Ireland are in attendance. And we expect this committee to grow as the importance of BIM evolves over the course of the coming years. And the scope and purpose of this group is very much to develop structured standards, specifications, reports that will specify methodology. So again, this work is going to be slower than some of the buildings that you're creating. But at the end of the day, the output of that will be to describe data exchanges, data monitoring of records, and indeed data security, to securely manage what you're doing. And I thought it might be useful just to give you a high-level overview of the various activities at the moment. So currently, there's this overarching committee. That then has 5 working groups underneath it. So the 4 main work strands within that. There's a work strand on terminology. There's a work strand on the exchange of information, equally one on delivery specifications, and finally a working group on data dictionaries. Then there's a 5th working group that's looking at, is doing horizon scanning, watching what's happening internationally on BIM development, and is looking to develop the development of a European BIM strategy. So that group works more as an advisory group to the main working group established in 2015, and then feeds into each of these as well. So these are the levels of activity that's happening at a European level. And I appreciate it's far away from your worlds, but it is creating, as you can see, it's creating the fundamentals of a new language, which will be crucially important. So then to give you a sense of the breadth and spread of this work, I thought it would be useful just to give you a flavour of the organisations that are linking in and liaising with the European Commission. I don't propose to go down through each of these, but I imagine these are more familiar names to yourselves than they are to me. And again, it's giving you an indication of the reach of European stakeholders that are feeding in at European level into the work of this committee. So equally, I would like to see that we can reflect that type of diversity in the work of our own mirror committee, such that we're bringing as many views as possible to bear on the work of relevant colleagues. Because if we don't reflect at this point in time the complexity of and diversity of our views, it will be formed by others, most particularly the others here on the screen. The European context is also useful in that it creates a forum for the committee that's dealing with BIM standards to liaise with all these other groups. So you can see here where the committee already sees potential interaction. So this is not just a singular, isolated development. So there's interaction with facilities management, with energy performance, with acoustics. And this is probably just the start. I imagine if I was back here in 6 months that this list will go even longer. And interestingly, the interactions of the committee are not just at European level. Equally, there are interactions at ISO level, so that's on a global basis. So the committee is engaging with archives, record management, geographic informations, and so forth. So there's connection with the committee at European level with broad stakeholders, and then there's also connection, there's lateral connections within the standards making world itself. So the key challenge actually will be to corral all of this information and make sure that we're not reinventing the wheel. But equally that if there's a body of knowledge elsewhere within the standards community, and I mentioned earlier to some colleagues, blockchain for instance, there's real potential to translate some of the findings from blockchain into BIM. But there's no point in reinventing that whole piece of work. Rather, let's take the output from that and translate it into here. So this is where this becomes much more exciting, where you see the challenges and opportunities opening up from other work that has been done. I thought it was useful just to call out the work that has already been done, because while standards work is slow and detailed, there is no doubt about it, but that there has been an amount of work done to date. And typically, you'll see from this list, again, I don't propose to go down through it, but the type of work that has been achieved so far revolves around the development of dictionaries, conceptual data schemes, trying to grapple with and understand coordinating acts and what links various activities together. And indeed, what talks about and how do we talk about the various business processes that are undertaken. So not just the technical data terms, but scaling up as well to business processes. So yes, it's going back to first principles, but you can see it's building layers. It's building layers forward in what will be a very secure infrastructure for the future. So that's the work at European level. You will see that there's ISO references within those standards, and that's because there's quite significant cooperation between Europe and international standards development. Very much led because both the chair and the secretariat of both groups is actually held by Norway. So there are advantages in just back to the human in having singularity of representation. So this commonality is hugely important because again it's going to avoid that duplication. And the joint partnership between Europe and ISO has a work programme that extends out to 2019 and 2020. So you will see output from this forum coming forward to you over the next 2 years. I think the importance of this is that it shows how the global work actually can potentially become local. And in that regard, the NSAI has a national mirror committee. So the purpose of our mirror committee, which is chaired by Ralph Montague, thank you very much Ralph for that, is to look at all of this work that I've described. So to look at the main working group in Europe, the 5 subgroups from that, the work that's happening at international level at ISO, the interactions with all of the other standards, bodies and worlds in terms of what's happening, and to take that back and distill it from an Irish perspective. So this is the current representation on the BIM Mirror Committee, and there's room for more people. There's room for people to be involved on an active participant basis, and indeed on an observation basis. So this is where Ireland gets the opportunity to make sense of what's happening and to influence it. And the real challenge for Ireland is, are we standards takers or standards makers? And that decision lies within the hands of lies in this room. Do we just want to take what's happening internationally and go with it? Or do we see potential to make and influence those standards? And if you see potential to make and influence standards, then this is where you need to be. You need to be participating in this group. You need to be engaging with this group. And there are lots of different ways of doing that. But the importance is that you engage with it. Because the group has quite a number of ongoing challenges. The first of which is, as I said, how we broaden the representation such that every relevant voice is heard and is given an opportunity to contribute. And I appreciate everybody in this room is very busy. This is crucially important. This is setting the language that we will all operate on in the future. Equally, there's the potential to not alone participate nationally, but to take that representation forward and to represent Ireland European and international level, and indeed to engage with colleagues in those fora, because again, one of the key advantages to this standards participation is that you're meeting with like-minded folk from other countries who are in the same position and drawing drawing positions. Our website will give you lots of details as to how to get involved. And I want to touch finally and very, very briefly on NSAI BIM certification. So we've been investing in this over the past year or so, and we're now at the stage where we're ready to offer a pilot certification on BIM. And we've engaged with a number of clients, but we are seeking a number more, and our certification process will be built on the existing PAS and also the draft ISO standard. So it's a further response to the roadmap, and I suppose ultimately we see that third-party BIM certification will become as important and as commonplace as any of the other core management standards, so that it'll be no longer ISO 9000, 14000, etc. This will be where the people, where you in this room will be required to participate. So on a broader basis, to conclude, the NSAI is also involved in supporting the roadmap through activities with the BIM Council, with working with other stakeholders to develop some of the other challenges within the roadmap in terms of training, in terms also of looking at engagement. And ultimately our objective is to eliminate waste, to make sure that your time and your efforts are productive, and that in the work that we do, that we give Ireland a significant economic advantage. And with that I will conclude, but those are our contact details for further information. Thank you.
Thank you very much, Geraldine. That was a really interesting presentation, and interesting to hear of your view on this fundamental new language that we all have to take on board, and also very interesting to hear about the national and international developments for BIM standards, and that a variety of views can and will be represented. I think that's very important. And it's great too to hear of the three roles that NSAI plays in relation to standards development, and that it acts as a conduit. Clearly, BIM standards will provide a reliable database for decision making in the future. And I think your message there towards the end, are we going to be standard takers or standard makers, really resonates with me, and it's something that I would encourage everybody in the room to engage with NSAI on, or engage their managers to talk to NSAI about, because if we're not there at the table, then we can't influence, and perhaps we need to be taking more of a leadership role in this area. So I think that very neatly segues into the next part of the morning. In relation to both Kieran and Geraldine's presentations, it's very important and very welcome that NSAI is committed to working with industry, to collaborating and engaging on this, and this will be very crucial for the future development of the standards pillar for the BIM roadmap. So moving on to our main case study this morning, I'm delighted to see that this brings a focus into BIM usage in civil engineering, specifically roads infrastructure. So I'd like to introduce Bart Loughton, Project Manager of Sustainability and BIM Structural Reliability for TNO. So he's a Senior Project Manager at TNO, involved in multidisciplinary projects related to information management in AEC and sustainability. TNO is the Netherlands Organisation for Applied Scientific Research. After his postdoctoral work at Stanford University in computer-aided design for construction, Bart was involved in several BIM innovation projects at HBG, a very large Dutch contractor at that time. And within TNO, he has subsequently worked on a variety of projects related to the further development and application of information management, including the initiation study for the BIM programme at Rijkswaterstaat and the European R&D project of ECOM. Currently, he is project coordinator of Interlink. So I'm delighted to welcome Bart to talk about the Interlink approach, using open standards for road asset management, road asset information management. Welcome, Bart. So yeah, I should have said that this is going to be a little bit of a double act, in that Bart and Angus O'Keefe are going to talk about two. Okay, wait.
Yeah.
Here? Sorry. So apologies about that. So Angus is an associate in ACI member firm Rowan and O'Donovan and has over 30 years experience in a wide range of civil engineering services at all stages, from conceptual and detailed design through to construction and asset management. He's acted as a project engineer and project team lead with a focus on asset information management and bridge design, and his duties include technical lead, project management and business administration. He's a chartered engineer, a BE in civil engineering and Eng Science in IT for architecture, engineering and construction, and an MBA. He leads Rowan and O'Donovan's BIM services and is involved in various industry committees and working groups on the implementation of BIM in Ireland. So he's well qualified to talk to us this morning. He's also a leading member of the CEDR Interlink Research Consortium. So I'd like to ask you to please welcome Bart and Angus, and they will talk about the Interlink project. Thank you very much.
Sarah, thank you very much for the introduction. Thank you all for giving us the opportunity, to give Angus and me the opportunity to speak about our project, Interlink. So we are very enthusiastic about it, so hopefully you too. Hopefully you learn something from it. Hopefully it drives your interest and that you investigate a little bit whether you can use something of it. We also hope that it might give some new ideas for your digital roadmap, joining forces in Ireland to get BIM really working. So the content of our presentation. Which one is? Oh, I will use this. Yeah. It's easier. After the introduction, I will tell. Angus will tell about industry needs. Because the role of Angus in this project is sort of the liaison between the research and the industry, and I'm more the representative of the research institutes. So Angus will tell about the industry needs, then I will tell you a little bit more about the technical solution. So what is our proposed way forward? It also has a video, so it's hopefully keep you awake. Then we have a little discussion on what you take with it from our presentation. And Angus will tell you about the test cases we are doing in the Nordic countries, the Netherlands and Germany. And then finally we give you our vision on how asset information management can be brought forward and some lessons learned. And after that we have some discussion. First short introduction of the project, Interlink. The client of this project is CEDR, which is the Conference of European Directors of Roads. So the 27 national road authorities in Europe. And 6 of those are from Germany, Netherlands, Belgium, Finland, Norway and Denmark. They joined forces in the so-called BIM group, where they first, they share their internal developments, but they also initiate research. And they initiate research to bring BIM to the next level, or the next step, to bring it to asset information. As explained by Geraldine, BIM focuses on the objects, the assets. And asset management also looks in how these assets are used and maintained. From the road authority perspective. So they are all struggling with that, and they want to learn from each other. And they want to be vendor independent, and so they also need some guidance to get there. So that's why they started the CEDR BIM project in 2015, and our consortium won with our proposal. So we started our project Interlink. So we focus on roads. It's But I think our approach is useful in other areas too, but our focus is roads. And the main aspect is that we are using linked data according to the W3C organization. So W3C is a World Wide Web consortium. People behind HTTP, etc., etc. So not something developed by civil engineers with interest for computers, no, by real computer scientists. And we think that's basis for a good basis for asset information management. And an important aspect also from the CitA is that we align with all the standardization efforts. And we saw long lists, and how can they use all those standards? And they want to do it, but there are so many, and where to start, and how to integrate those. And they want to share their best practice. So this project started nearly 2 years ago, and will end in autumn. And our main project is a European road object type library. So a definition of the data structure, and when you exchange or share, preferably, data about roads, assets, etc., and other assets. Now, we tested this in 3 test cases. And our consortium, its list is there, and I wanted to put in the logos, but I forgot. TNO Research Institute in the Netherlands, ROD, Angus Engineering in Ireland, Royal Haskoning, engineers in the Netherlands, AC3 software engineers in Germany, Dribble, so the big company in the US, but a department in Norway, Semtech, a small company, linked data experts in the Netherlands, II Interactive Instruments, mid-sized company in Germany, very active in Oxtra, in data exchange, and Plan Wow 4.0, which is an industry-led initiated organization to promote BIM in Germany. So it might also be interesting for you. The project, I won't go into that, but this is the whole project starting in September 2016, ending this September. We are on the right side, so we've done most of the work that we are wrapping up now. So developing our object type library, developing some software to work with it, and doing test cases. Now we'll report about the road OTL and the test cases. Now we're just disseminating like things we do here. Okay, let's start with. Doesn't work. Bottom one. Yeah, here. We start on this side with the industry needs. Angus will tell you more about it.
Thank you, Bart. Good morning, all. So as Bart said, I'm looking at the industry needs. So as a civil engineer, my job on this project is to make sure we have a strong connection between the needs of the industry and the capabilities and developments by software companies, standardization bodies, data scientists, and the like. And that isn't necessarily straightforward. Always grappling with trying to avoid the data scientists and the software companies focusing on their interesting problems and trying to find a useful solution, find a useful problem for a nice solution that they have, which I would argue is the wrong way around. We need to have a clear understanding of the problems and then identify good solutions to those problems. So it's a very interesting role. And in the first 6 months of the project, we had 2 work packages. One looking at the business needs for information, and one looking at the data needs to meet those business needs. And in order to do that, we started with an engagement across the consortium. As Bart said, we had a broad-ranging group of experts from domain experts in the world of civil engineering and asset management through to IT experts in the world of software and data science, as well as research experts. So we worked together to come up with a preliminary set of where we saw the industry needs. And we then conducted a literature review, working mostly with a lot of more recent literature reviews from other broad-ranging projects. We conducted over 64 interviews with project managers from roads authorities, asset managers, software companies, consultants, and contractors from 11 countries around Europe. We then surveyed quite extensively based on our findings from the interviews, sat down and analysed the outcomes, and ultimately came up with a final set of needs statements. The diagram here, obviously you can't read, but that is our sort of summary view of the business processes at a very high level, the business processes in the world of road asset management or road network management. And the view, when we come from the world of design and construction and BIM, we always think that everything starts when you have a new project. You come up with some options and you do a design and you ultimately hand it over. But in the world of the operation of road networks, you're starting with an extensive set of assets. And if you find you need a new asset, or you need to maintain an asset, or you need to reroute a road, you then initiate a project. And it is a different way of thinking about things, and I think those of us in the world of design and construction and BIM need to be quite cognizant of that. So the red and green on this diagram, it's available on our website, which and I do encourage those of you who are interested to look at it. But the green parts represent where we see things working quite well. I'll talk a little bit more about that. And when I say well, it's really a sort of a typical view of, or a typical condition across countries that are considered quite mature in the area of information management for road infrastructure. The parts that are red are the parts that we see there being problems. And as you can see, there's a lot of red. So even the countries that are very mature in asset information management are seeing a lot of issues. So that's quite a high-level view, but is based on a lot of work. And then we have in parallel a poster which contains the 36 needs statements, roughly categorized into business needs and data needs. Of course, there's an overlap between the two. And that is essentially our set of requirements. So like if you're developing software, you would have a set of functional requirements. This is like our functional requirements for information management in road infrastructure. And it's always at the forefront of my focus when the test teams are working on very detailed testing and modeling of information. How are we actually meeting those needs? I'll just talk through the various stages then of the life cycle and what I see and we in the consortium have reported on as working well and not working well. Again, with a focus on those countries that are quite well advanced. So for network operations tend to be quite well developed. You've got intelligent transport systems. An example of it here, Transport Infrastructure Ireland are investing quite heavily at the moment in intelligent transport systems, and they're well implemented internationally. And they use national and international standards for data exchange. So DataX2 is one of the examples that's quite well adopted internationally. But for road operations, unfortunately, we have multiple operators. So we might have PPP companies. The national road authorities, local authorities, of course, like Dublin City Council or other authorities, and they would often, in most cases, have silo systems where they manage network information, whether it be traffic information or control information, and the systems don't necessarily speak to each other and might use disparate data structures and standards. So that's a real problem. And therefore you end up with either duplication of information or conflict between pieces of information. Moving then from network operations to looking at investment decision making about the network. So at some point the road authority will say, right, we have on the right here, you can see the Irish National Road Network, on the left the Danish National Road Network, and somebody decides we need to invest in maintaining our network, our stock of assets. Someone else will say, right, well we now need a new road from A to B, or we need to widen a road from Cork to Limerick, or whatever it may be. And there's an investment decision made there. But the problem for information management is projects like this are very long scale projects. It could take 10 years from the time that you conceive a new road to the time it's actually handed over to the road authority, or even to the time that a PPP company is operating the road. And therefore you get a very delayed feedback on decision making. If you're at the start saying we want certain data standards used when we receive the information at the end, then how are you going to know? You can't know now what future standards your asset information management systems will actually use. That goes back to Geraldine's point regarding the future-proofing of asset information. Some countries are really good at the systematic gathering and feedback of information, particularly for an example in Denmark. But analysis of that information then is inhibited by the format. So they're very systematic in how they gather the success of their investment decision making on their investment projects on road maintenance and new roads. But it's report based, and it's very hard for them to collate all the information that they're looking to improve that. And often you'll see that there are project managers and asset managers who will have ideas about information management, but there isn't necessarily a cohesive vision, or in UK terminology, a set of organisation information requirements that are well defined with a top-down leadership vision. Looking then at capital works projects, this is tends to be an area where things are quite well advanced. It's very well established. The use of BIM for design and construction is well established, particularly in Scandinavia and the Netherlands. UK is catching up to an extent, and Ireland less so. There is a problem at the outset of projects that historical information is very difficult to find, and often the quality of the information may not be known. So how accurate is that information regarding utilities or ground conditions? And particularly projects get paused, so you might have a lot of work done to get a project to planning stage. Maybe there's no funding then for 2 or 3 years. People move off the project at NRA level or at consultant level, and you lose a lot of information. There's some very good work internationally around the employer's information requirements, or in some countries they'll call it the Information Delivery Manual. Germany has standards like Oxtra in the Netherlands, Coins, and Rijkswaterstaat Object Type Library, and GIS-based standards in Norway, such as SOSI, and more in other countries. So there's really good work done there, and the supply chain is up to speed with how to deliver information according to those standards. There are problems, of course, then when you get third parties involved. A lot of exchange of information as opposed to sharing of information, so people sending files, putting them in common data environments, and you then have duplication, you have issues with quality, you have issues with versioning, and a lot of loss of information about the function of assets. So we all hand over detailed information about the assets at the end of the day, but what was the original function of that asset? And often that piece of information is lost or hidden in some report somewhere. Geotechnical information in some countries is managed very well, for example in high-res England. And design approval, the information around design approval, there are good processes, but again, how that information is gathered is difficult. Construction tends to be very good, so the exchange of information between designers and contractors, and that has helped because roads authorities in the more advanced countries have published their asset information requirements. So then when contractors and consultants see the employer's information requirements on a specific project, they know already that their systems are compliant. They don't suddenly have to modify their systems for a specific set of employer's information requirements that are maybe a favoured approach of a particular project manager or asset manager. When we get to handover then, this is the big problem area. Even the most advanced countries, they have a real problem with getting information from contractors and getting it into their asset management systems. A lot of manual intervention to get information into asset management systems. Some countries have invested very heavily in their asset management systems. Germany has extensive SAP-based systems. In Norway, they have very good national roads database, NVDB, but they really struggle to get the information into those systems. So it's not efficient. The assets themselves aren't necessarily, they're not discretized in the systems. So they don't, you might have documents that, and models and drawings that provide information about assets, but the assets themselves aren't necessarily uniquely identified in computer-based systems. So it's difficult for contractors then to get that information across. And again, the employer's information requirements are inconsistent. And even where countries have very good employer's information requirements, they find at the end of the project that payment is associated with the delivery of the physical assets rather than the information. So the contractors focus a lot more on making sure that they get the construction complete and handed over, but that the information is secondary and doesn't drive their payments. And ultimately this can affect trust of information. And in asset management then, when they actually get to asset management, there are a couple of diagrams here from the National Roads Database in Norway. They've publicly available, really detailed information about all sorts of assets, very impressive systems, and there are really encouraging advances. But in a lot of cases, though, the asset management systems are not necessarily connected to each other. So the bridge asset management system and the pavement asset management system are separated, and even when countries and roads authorities invest very heavily in sophisticated single software systems, the different parts of those systems for specific asset managers aren't necessarily speaking to each other. So they solve the problems of individual asset managers, but not necessarily of the road authority as a whole. And that can also can result in significant vendor lock-in for roads authorities. Another big problem for roads authorities at asset management stage is that they often operate with term maintenance contracts, so they could have 3 to 5 year term maintenance contracts, and those contractors gather a huge amount of information about the assets over the time of maintenance, but then the road authorities have a lot of trouble getting that information effectively back into their asset management systems, which means they have to pay another contractor to gather all that information for the next term maintenance contract, or that the preceding contractor incumbent has an unfair competitive advantage. So where does that get us then in the industry's needs? So roads authorities really should publish their information requirements in advance, gather information throughout the life cycle in the best available format. So ideally internationally standardized formats, but if not, then at least the best available format, gather it as you go. We'll talk more about how that can be connected to the assets. Use open standards, of course, and access information through both GIS and BIM. We speak a lot today about BIM, but GIS is fundamental for the management of a large stock of geographical assets. That information management functionality should be based on use cases. So don't put people in a room for a year and come up with a really nice library of how all your your asset information should be managed, make sure that it's actually based on use cases. And that led us to be able to recommend to road authorities that linked data and standardization, that road authorities should provide active contribution to the standardization, that they should share information and be open to using open standards. That in capital works projects, make sure that there are requirements to validate the information that's handed over and certify it, so actually have a liability associated with the information and not just a liability associated to the actual physical assets that are handed over. Start small. Don't try and develop the model of all models, and to learn from each other. There are plenty of countries who are well advanced but learn lots of mistakes. So I don't necessarily think in Ireland that we need large-scale pilot projects to prove our points, because others have done that for us. And of course, we want the software companies to buy into this, and we'll talk a little bit more about that. And we recommended to the supply chain that they engage with the Interlink consortium. So Bart will now speak to you about the technical solution.
Okay, so we heard that there are a lot of questions from the industry, a lot of needs, and so let's see what technical solution we are proposing to solve at least part of those needs. And to do that, I will give a little sort of lesson about linked data to get you a bit more familiar with the whole idea of linked data. So explain what the value of linked data is. Then I go to the European Road Hotel, so our main product in this Interlink project. Explain a little bit more about the Interlink approach and give a practical example. So let's start. What is linked data? So typically a lot of data today is stored in relational databases. So in a relational database, you have a table like an Excel sheet with rows and columns. Rows are, for instance, assets, and in the columns you have attributes like the length of a bridge. And in a relational database, typically this is fixed. So it is a fixed number of attributes, and you can of course have as many rows and assets as you want, but the attributes are fixed. In linked data, you start from the data itself. So in linked data, you describe the whole world in little sentences with a subject, a predicate, an object. So that's the theory. So a gantry, it's one of the gantries shown by Angus, a specific gantry with an identification, as a location with 2D location. So in advance, nobody knows that the gantry has a location, but it's defined like this. And the gantry also has an owner. You get to the NRA as a contractor. So you can imagine that with these simple sentences, you can build up a data model of the whole world. And to make it a little bit more easy for a computer to recognize that this gantry number 123 is actually a gantry, you can define that this specific subject, gantry 123, is of type gantry. And then you can tell the computer that gantries in general have location, for instance. Gantries in general have an owner. So then the computer can sort of go through all the data, this whole network of linked data, and find all the gantries and find all the owners, for instance. Or put all the gantries and put them on a map using this 2D coordinates. Now, this is the data structure in blue, but you can refine further or say more. And a gantry is a subclass of an infra-asset. Then an infra-asset can be used by a contract or by a national road authority. And the 2D coordinate system can be a subclass of location in general. So this is the data aspect and linking data, but data doesn't have to be on your computer. It can be anywhere in the world, because you can find it with a URL. So there's data on this computer, then again free information is on this computer, and the location, the GIS map is on the computer of a contractor. So with a URL you can find it through the World Wide Web. So typically, so the orange is the linked data, and when you add the blue, you add semantics to it. So that's sort of the theory behind linked data. And that's what we are using. So this is sort of an evolution from one-star data at PDFs. It exchanges PDFs, a human can read it, perfect. But a computer cannot do anything with it. And you can sort of advance through Excel data, and in the end, linked open data. And what we say is that the world will not change from 1 star to 5 stars at a blink. There will always be different levels of information. So it's a hybrid situation. And so we should acknowledge that and support that. And we think that using linked data can be the glue between all these levels of information. So, what is the advantage of this linked data semantic web approach? First, we focus on data. And data is the common factor between all the partners, participants in the supply chain over the life cycles. And we think data should be liberated. So it should not be hidden in computers or in applications or in documents. It should be freely available. And it should be linked. So data should not be copied and sent to one central place. It should be kept at the source. So the road authority should maintain its own data and make it available to the contractor. So the contractor always has the up-to-date information. Then we say we use the web technology. So we base it on the W3C technology, and thereby we are certain that we have a large community of developers behind us. So we don't have to invest in that as civil engineers, and we can use the knowledge of a lot of others. And with semantics, we add meaning to data. So it's computer interpretable. So it's not only readable by humans, but also the computer can infer knowledge out of it. Artificial intelligence, things like that. So what we think is that linked data is a very powerful technology that can help us to meet all the challenges and all the needs as explained by Angus. So we are not sure whether it's the only one, but what we are sure of is that a lot of organizations and standardization bodies are moving in this direction. Now, what did we do with this linked data? We built our European road hotel. How do I get to the next? Just click the next. Yeah.
Asset information management using linked data for the life cycle of roads. Exchanging or sharing information about roads between stakeholders in the construction industry across the life cycle of roads is complicated and vital for national road authorities. Road asset managers, contractors and their suppliers, consultants and engineers all require information regarding the planning, design and maintenance phase. Sometimes information about roads is missing or repeated with different values. This leads to inefficiency and additional costs. Computer technology enables us to create a digital twin of the road and its data in the computer. Using linked data and semantic web technology enables computers to link the data and its meaning about the road from different sources to each other, allowing them to be fully integrated. How to create a digital twin of the road? Stakeholders in the sector provide structure to their data by breaking down the road into different components. Such components might be roads, pavements, guardrails, lampposts, or lighting. These become object types associated with specific properties in a digital object type library, or OTL. It provides the backbone of the digital twin of the road. The data required for managing the road can be structured according to an OTL. This provides an efficient exchange and sharing of information about the road between stakeholders across the life cycle of the road. The Conference of European Directors of Roads, CEDR, initiated a research program in 2015 to create test cases for an interlinked network of existing OTLs. Oxtra in Germany, CBNL and RWS OTL in the Netherlands, CoGlass in Sweden, SOSI in Norway, and International IFC, based on the same IT design principles, and to establish a guide to demonstrate good practice IT modeling and linking principles. Together, this is called the European Road OTL. Another advantage of the European OTL is that IT developers and road asset managers can agree on a standardized IT modeling style. This is because individual IT modeling styles are a barrier for linking possibilities. Standardized IT modeling and linking principles are a crucial part of the European Road OTL. By doing so, road asset managers can benefit from the structured data according to an OTL and its linking possibilities. Working according to these principles is beneficial because various different sources of data can gradually be linked together without harmonizing the whole world of road data at once. CEDR members have an interest in networks of OTLs and linked data semantic web technology to fulfill their operational needs. In the current data landscape, data often becomes trapped in individual software applications and individual OTLs. This is a barrier for data integration. An advantage of the new approach is that it frees the data from its individual application. Because of this, it becomes possible to integrate data from various sources: GIS, BIM, asset management systems, geographical survey, and other legacy systems. Data exchange or sharing between partners becomes more efficient, which leads to fewer failure costs and better affordability of national roads. This approach was developed and demonstrated by Interlink, a consortium of market parties and research institutes focused on this issue. Interlink delivers a roadmap for a seamless transition into an open, available, standardized, integrated European road OTL framework. The Interlink approach enables European road asset managers to manage their roads more efficiently due to data integration, resulting in fewer mistakes for everyone, leading to more affordable roads across Europe. To find out more about Interlink, visit the website www.roadotl.eu.
Okay, so hopefully this gives you a picture of what we are working on. I'll go a little bit deeper on this European road OTL.
Asset information management
it's not.
using linked data for the life cycle of roads.
There's the escape on the Mac.
Exchanging or sharing information.
Yeah. So the European Road OTL is a sort of framework of OTL. So typically, each standard presented by a gentleman comes up with a data structure, an OTL. So how do you use those together? And so which one are you using in your project? Because there are dozens. They are then show the international ones, but there are also national ones. So how do I select ones and how do I combine those? So, the European Road OTL is a recommendation, it's a library of libraries for NRAs. each NRA can, we make a recommendation from, we advise you to use this, this and this, OTL. National road authorities can choose. Our approach has been tested, and testing was also sort of development. So we used the test also to develop our with the European road OTL in the end. Road authorities can gradually evolve from the document-oriented systems to more data-driven asset information in a hybrid solution. So some will be still document, some will be relational data, some data is in a relational database, others already in data. As explained in the video, they can make use of the modeling and linking guide. So this will help to make the OTLs uniform so that you can linking becomes easier. And what they also could do is reuse the OTLs that are sort of recommended in the European. So, what is in the European Road OTL? First is the modeling and linking guide. So here we define from an IT perspective how you best use modeling languages, how you define attributes, for instance. From an IT perspective, but if it's uniform over several OTLs, linking becomes really a lot easier. So the kernel of our European Road OTL is the network. And we think the network is the road network from A to B with roads in between, and then we have two roads crossing, and then the cross becomes also a node. So this whole network is sort of the thing that all partners in the whole life cycle of an asset have in common. So there is an international standard for transportation networks, Inspire. So maybe you are using it, I don't know already, but so for instance in the Nordic countries it's used quite a lot for all this open data, and we use the road network part of that. So that's sort of the kernel. And the asset lifecycle, that we say each asset, doesn't matter what you're looking at, has life cycles from conception, construction, maintenance, inspection, when it's closed down. Next to that, what we often see in a lot of OTLs, people start with these very common concepts like location or length. They start defining that. And each standard does it again. And we say, please use existing standards. For instance, for quantities, NASA has done a lot of work on that. We cannot pretend that we can do better than NASA in the US. So let's use their definitions. So now you have metadata, data about data, who created this data, location, in time, not clear, and the quantities. So when you have that basis, so the red, yellow, and blue, and then you can have the domains, the related domains, like inspection or maintenance. And all the other standards shown by you. So that's on the international level, and then on a national level, you would link that to your national classification systems. And so the German classification system, Oxtra, very well defined. So we are not going to redo that, and they will use it. So the basic European road OTL has its links with existing standards. So on the top you see the international standards like IFC. So we will not change the industry foundation classes. And it's development on its own. with a lot of users, etc. So we say make use of that standard and make sure that our network can link IFC. And the same on the right, GIS, the geographical systems. And at the bottom, then you see the national level, and we want to link to Oxtra, the German. So there is a link with the Oxtra classification system in Germany, and the Germans might want to use it, but you in Ireland will not use that. That's the European Road OTL. And you, so yeah, you are our liaison with industry. You give a practical example.
There were lots of discussions on how we manage certain pieces of information and types of information, and I was struggling to take that conceptual discussion to a tangible example. So I found this helpful. This is the location of the Nordic test case in Jæren in Norway, where a motorway was designed and constructed and delivered to the client over the last few years. So for argument's sake, say that motorway, if we can overlay a very simplified network model on it with a couple of nodes, so a road node at the top and another one at the bottom, and a road link in between them, and they have some unique identification associated with them. And then in the middle there with the red dot is a lighting column, or a lysning in Norwegian. And the road authority wants to manage information about that lighting column. So each of these, starting at the data level, as Bart said earlier on, each of these pieces of information can be connected to each other. So the INSPIRE transport network is a European directive around the management of geographical information, and that allows us to, with linked data technology, to say that a road link has a start node and an end node, that it's part of a certain network. And then we can use national and ontologies and European road OTL, the outcomes from Interlink, to say that a lighting column has a certain location. So on the pointing. So the lighting column has a location, and that it's of a type which is a Norwegian lighting object. And then we can say that the lighting is a European Road OTL asset, and because it's an asset, it might bring in other requirements around provenance of information about that asset from established international standards for data provenance. We could say then that the road node has a junction number, say junction 5. Of course, when we're talking about road nodes, we're not going to use a long code. We'll talk about the junction number. And then we could say, for example, so this is all linked data and computer readable information. Of course, then there might be a specification associated with the lighting column, and that specification might be in PDF format. But at least you can link it back to the lighting column object, so that that information can be found a number of years later, or by the contractor, or whatever. And then we could say that specification is a view on the functional requirements of that lighting column. It may subsequently be fulfilled by a physical lighting column and a lighting bulb that meets those functional requirements. And then, of course, you can run standardized queries to actually find information. For example, road authority, you might say, like, list all lighting columns on a certain motorway between junctions 4 and 5, and you might be able to use, not might, but you can use straightforward, user-friendly interfaces, and in the background it's running open standards-based queries to return the results of your particular query.
So you saw that when you're using this approach, you are able to combine standards national standards, European standards, but also your own definitions. So you're not restricted to what some kind of committee has defined 5 years ago. So you're always able to add your own standards and your own definitions to it. It doesn't have to be standard, it can just be the information you need at that moment for that project. So with with our approach, that's European approach, OTL. So at the national level, what you could do is make use of this modeling and linking guide. So make all these standards, data structures uniform. Next step is that when you have done that, reuse OTLs that are part of the European road OTL. So maybe you're interested in inspection, but not in traffic. So then just only use inspection. That's on the national level. So on a European level, what we would say is, what we advise the national road authorities, share your experience and share also your object type libraries. And don't be protective about that, share it. Reuse what others have done. Don't start from scratch, you really don't have to do that. Always somebody has already worked on it. When you have several OTLs, for instance, for inspection, you might say that the German one is the best. So let's define that as best practice. Next step is that you also might say, okay, the German is the best, but the Danish inspection model also has some qualities. So let's harmonize and make European standard, or not European, an OTL we share as 3 or 4 road authorities. Next step is you could also standardize. Go to your national standardization organization and say, we propose this European standardization. But you don't have to wait until the standard is ready. You can already start. And I also think that standards that follow this route, so bottom up, using are stronger and are highly more probable that they will be accepted. Okay, so this is our European program. No, we don't have time for discussion.
Maybe
at the end, yeah. Okay, then. Yeah, I can give you some feedback what we have learned in the Netherlands. So we have been involved in this asset management, asset information management since 2011. Rijkswaterstaat, our Dutch National Road Authority, started in 2011 with the feasibility study, pilot, etc. Since 2014, the largest road projects in our country, were sort of appointed as a real-life pilot. So they said there's a lot of money there, so let's also use that money. Let's use a little bit of that money for a new ICT approach. So the road reconstruction from Schiphol to Amsterdam to the polders. Several billions of euros. So in 2014, there were 5 projects there. Now for all new serious projects, they prescribe. In their information delivery specification, they describe how contractors should provide their information, and also with liability, etc. And they're also now starting to use the same approach for large maintenance projects in roads. And some of the achievements have been incorporated in the TC 442 for international standardization. So that's sort of the thing. So, but also some lessons learned. So what we see is that the major project department made large steps, but the asset management organization itself lagged behind. And so yes, Rijkswaterstaat now has a lot of information, but getting that into the asset management systems is still problematic. So we say, don't start so big, start smaller, but start wider and making sure that different departments in your organization are on the same page. This project started in 2011, so they really focus on exchanging data, so sending big zip files with a lot of information. Today you could also share data, and you could also make much more use of the power of linked data. So they use some of it, but not all. So there are more, things you can learn from there. It was also sort of top-down. So Rijkswaterstaat, the road authority said, you should do this, this, and this, and we say, take your supply chain partners more at hand, and also the other authorities. And so, last advice, last lesson, and they made one very big model, of course inspired by standards, but they copied the ideas, for instance, from the network, and they made their own network, inspired on the Inspire network. Now, Inspire changed, but this, it's very difficult to maintain this big model of role models. So we should advise to slice it up in separate. The 3 test cases.
Okay, well, I'll just present briefly the 3 test cases that were run before wrapping up. So there was one in Norway and Sweden by our partners Trimble and Triona, in Germany by AEC3, Interactive Instruments, and BAM 4.0, and then in the Netherlands by TNO, Semtech, and Royal Asconic DAV. So we were not only trying to test the outcomes of what was being proposed for the European Road OTL, but also to provide input to the bottom-up development of that object type library framework. And we wanted to demonstrate that the business needs can be met and to use existing commercially available software and to help NRAs to understand how it can be implemented. So in the Nordic case, I spoke already about the road lighting. This is a part of the model of the road in Yaren, which was using very good software from Trimble, and looking at the road lighting objects in that. So, okay, so in the Nordic case, in the Norwegian case, what they were doing was trying to address this issue of gathering information throughout the full life cycle of the lighting column, and there's a problem there in Norway where how do they get design information, construction information, through into the asset management system. So what they've done is uniquely identified individual lighting columns, and then they're using linked data to link those lighting columns with functional requirements, the design standards for those lighting columns, and the lighting units themselves, the functional requirements, so what lux or illuminance level is required at the road pavement level, and how do you associate that both with your network model and with your alignment model. So there's a lot of integration of international standards for various types of assets, like the road surface, the network alignment, the lighting columns, but also with photos of lighting columns, with data sheets for lighting columns, and the likes. And what's been very interesting in that case is that internationally used commercial software can be easily extended to accommodate the functionality, and that's really important for the potential success of the Interlink approach. In the German case, they have an interesting case. They have a bridge in Hamburg. So we were looking initially at the traditional approach for delivering a bridge project in Hamburg, but also this is one of the pilot studies for BIM for Infra 2020, which is the German sort of similar approach to the UK. They want to implement BIM and mandate in 2020. But the pilot study is using a detailed employer's information requirements and specifying open standards like IFC that Geraldine mentioned earlier on, and national standards like OPSTRA in Germany. then the third view is the interlink approach and how can that potentially benefit things. So the bridge was modelled by consultants in Germany under a separate project in Revit and exported to IFC. And that then, when we converted that to linked data, it went to an extremely large file size, which was too much to handle. But what we did was we decided that we strip out all the 3D information. We don't need the 3D information because that can be managed otherwise. To actually manage asset information, you don't necessarily need the 3D. Convert that IFC then into RDF, into triples, using a tool provided by Building Smart International. And link it then with the German classification system for bridge structures as May. And that is a really interesting case, which arguably in some ways is moving towards what the UK would call level 3 BIM. We're still quite a bit away from actually having that in industry, but it's interesting to see it in practice here. And that's then at the end, you can take your individual bridge objects, link the unique ID of any one object back to the 3D information, and query information, and for example, link the results of a condition survey of a bridge deck, which might be in poor condition. Some engineer might have gone out and done an inspection and link that back to individual objects within both the information model and the 3D models. Very interesting. And in the Dutch case, looking more at the asset management stage, where, as Bart said, the Dutch are quite advanced in many ways, but they have a big problem there where they have maintenance contractors who will inspect and maintain assets, and then every 3 months they'll hand over a big zip file of all the results of their inspection and maintenance to the road authority. But key performance indicators are really based on their day-to-day inspections, so the road authority struggles to really understand the performance of the contractor. And this test case was looking at connecting, allowing the inspector to view shared information through a web app, so actually based on their location, find the asset they're looking at, maybe a barrier or a piece of pavement, and select what their view is of the condition of that asset, and push it back into the road authority's system. And to push it back in a way that it's provided for information, so again, maybe using the suitability language from the UK, which has been pushed through at an international level in potentially ISO 19650. So identifying it as for information to keep the road authority up to speed on the progress of the maintenance contractor, and then over subsequent time actually formalising that submission by changing the metadata associated with it to perhaps for approval. And that's been, again, a very interesting case of how can linked data being used in this way actually bring existing mature countries even further in their use. And a lot of use of GIS as opposed to BIM. There are the slides. So I will move past these and just wrap up with our vision for asset information management. So as Bart said, data should be liberated and shared. The mother of all models, the big mama model, doesn't exist. We can't model the whole world in one model. We need to be able to combine the best of multiple models and multiple standards. And the ICT landscape will be hybrid for a long time. We need to acknowledge that, and we believe that the linked data approach is the glue between them. We encourage organisations to develop their OTLs from the bottom up, so really based on tangible business needs and not based on people locked away in a room for a long time. A roadmap for your organisation would be, perhaps to strategically choose the data orientation using open data standards. And this, I think, is consistent with what's envisaged in the National BIM Council's roadmap. It's a very well conceived document, and but it does need that next step, I think, of course, national investment to I believe is encouraging news potentially of funding for the next stages of implementation of that in Ireland, but it also needs a vision, and we believe that vision should be around linked data as being a part of the solution. Of course, it's not all the solution. And define your framework in a modular way. So lots of pieces that can be connected together. Don't try and do it too big. And our suggestions for joint efforts, so as I said already, do it on a small scale, share knowledge. We need a shared vision on asset information management. And it's interesting to see we have a representative from Transport Infrastructure Ireland today here, who are responsible not just for road network management, but also for Lewis Light Rail and for Metro. Rijkswaterstaat in the Netherlands are responsible for roads and water. Traffic Forget and Sweden are responsible for road and rail. And a lot of what we're talking about here today is applicable across lots of asset types, arguably into other domains outside of physical infrastructure asset management. And that's really important for the success of this across multiple industries. We could even apply a lot of the principles in healthcare or oil and gas or things like that. So please do follow what we're doing. Engage with us. Learn more from organisations like Building Smart and organisations responsible for GIS standardisation like OGC. As Geraldine said, engage with those organisations, and hopefully we will see a gradual transition towards this approach over coming years. It's interesting in the UK, just a final point, the UK, their digital built Britain vision for after 2020 highlights that linked data and semantic web technology is something that they need to facilitate their vision. They're not yet moving towards that, whereas other countries are. And I think that's an important point in Ireland, that we shouldn't just look at the UK for our best practices, that there are other countries that we should learn from more. Thank you.
Thank you very much, Davis and Mark. I certainly learned a lot there. It's fascinating to your overview of it, how everything links together, and this idea that data should be both liberated and shared, and the way in which you can do that. I'd like to ask Bart and Davis to come back up here now. We have time for some questions. There should be some questions if you'd like to. I'd like to open the floor and the question.
Hi, thanks very much. Excellent presentation. One of the questions, you talked about open data. So when you got open data, did you release it with a CC BY license? And if you did, how did that affect copyright being relinquished from the creators to allow you to do that license?
So in the linked data approach, data is stored at the source, and the source also manages who has access. So I might have a URL to some piece of data, but if I want to access it and I don't have the rights, I want to get into it. So that's sort of part of the solution. Part of your answer. So, yeah, what we see today is, for instance, in Norway, with this, where the road authority has made public a lot of the road data. They have selected this and this part. I have to, and I want to make publicly available. So, yeah, I think you have one-on-one decisions and agreements between partners. So, what is available and what can you do with it? But linked data on its own doesn't provide a general solution for your data ownership issue.
But was it a CC BY license that you used, or what was the license?
A new Creative Commons license. So in the actual test cases, the information is managed in a privately accessible triple store, which is mimicking various systems. But there are, for example, there is linked data already published by Ordnance Survey Ireland. All of the boundaries on a county and local level in Ireland are already represented publicly in linked data format. You can query that with suitable software, you can download it and look at it. They provide that with certain licenses, so it's not necessarily provided through Creative Commons, and I'm not IP and copyright is my area of expertise, but so we recognise these issues, but we're not necessarily making recommendations as to how all of those issues need to be resolved. That's arguably another day's discussion by others who are experts in that area.
Good morning, it's John Duffy from Transport Infrastructure Ireland. First of all, congratulations on a fantastic presentation from Angus and from Bart, thank you. So, first of all, I just want to say I'd like to get the presentation, take it back, and of course circulate it within your own organisation. And then secondly, a couple of questions. I'd like to know if there is a plan to extend the test cases beyond the 3 test cases that have already been done. And the second part of my question then is, have there been metrics established to measure the future success of the implementation of the framework?
Yeah, on the test case side for extension, we are in the early stages of extending the test cases, but outside the remit of the Interlink project, which is actually encouraging. In an Irish context, I can't necessarily talk about that right now publicly. I can talk about it afterwards with you. And I think that potentially will help with, you were saying you'd like to take the presentation away to TII, and perhaps we could see how because obviously ROD and other consultants are involved in TII across multiple aspects, whether it be roads, light rail, and asset management and ITS. And I think there are lots of opportunities there for potentially trying to achieve a common vision for the future across the organisation in TII, and perhaps small, low-budget test cases can help with making that more tangible for decision makers. On the second question.
So we don't have metrics on just before and after. So it's our tools are there for our test cases, sort of proof of concept. So we prove the concept, we prove that it adds value, not quantitatively but qualitatively, and we prove that it is feasible to do it. But we don't have metrics, but we will definitely end with a sort of list of these are the added values for comparing before and after.
Thank you very much. Our final speaker this morning is Rob Ruth from Graphisoft. Rob originally trained as a civil engineer. He's known as a BIM captain in his own world. He works from Rotterdam and has a lot of BIM experience. And currently he's heading the Global Open BIM program at Graphisoft, which is a leading BIM software vendor, and is heavily involved in building Smart International, where he's leading the airport room, sounds fascinating, which is a user-specific interest group striving to implement open standards on a global scale. Rob describes himself as an open BIM evangelist, and he truly believes that the global construction industry benefits from the transparency and future-proofness of BIM. The title of Rob's presentation today is Open BIM, It Works.
Thank you very much. I have to warn you, I suffer from TMS. It's too many slides. Yes, nice to meet all of you. I run a small consultant company in Rotterdam. It's called BIM Captain. That's me. That's the only employee. And I've got a couple of clients. My biggest client is Graphisoft, which I work 99% for. I work a couple of hours a month as a boardroom consultant at Amsterdam Schiphol Airport. And further, I work within the Building Smart organization internationally, and I will touch all those aspects. So first to start with, I work with Graphisoft. This is the nice facilities we have in Budapest. That's my head office. I'm going there after this meeting. And Graphisoft is part of Nemetschek. I'm not sure if you know what Nemetschek is, but Nemetschek is a very large organization, and there's a very strong philosophy that we need to follow open standards. It's in our DNA, all over our branch offices and all of our brands. The brands that you are familiar with are here in the bottom. So you see Graphisoft and Solibri and Vectorworks, but we have an Outplan. So we have a lot of different brands in the group. And again, you see 4 pillars, and one of the pillars is that we are very open. Our CEO, the CEO of Graphisoft, is Victor Varconi, and he is one of the 3 members of the executive board of Nemetschek. And again, publicly, he's always speaking about the openness and our open BIM approach. So you can see, open BIM is not something that we do on the side. It's something that is really important for our organization. And that is brought back into the brand identity of Graphisoft. It's all about virtual building. As I said, it's very fast on those slides. Graphisoft was founded or established in 1982, and it was founded by someone who came under the, or who break through the recession that was during the time, and it's Gabor Bajor, and he smuggled some computers from Austria to Hungary. And at that time, BIM was born, or virtual building was born, because he had to create a system, an MEP system into a factory, and he invented class detection there. And there was only one computer that was able to do that in 64K, and that was a computer. And since then, we were always in a very good relationship with Apple. And we developed on Apple and on Windows, on Microsoft. In 1995 already, we joined the International Alliance for Interoperability, that's now called Building Smart. And in 2012, together with some other industry software companies like Tekla, now part of the Trimble Group, we launched the Open BIM program. And I encourage you to Google the Graphisoft story on YouTube. It's amazing. It's explaining where we're coming from and where we're going. It's really nice. It's a nice YouTube movie. We have approximately 10 subsidiary offices. We have operations in 100 countries, and as I said, we have the HQ in Budapest, and I'm here to support Graphisoft UK, for over years winner of the Construction Computing Awards by the Hammers as the BIM Product of the Year, which of course we are very proud of. This is the official, it's the Building Smart Open BIM description. So it's a universal approach to the collaborative design, realization and operation of buildings based on open standards and workflows. So it's not only open standards, not only files exchanging, it's workflows as well. It's an initiative of Building Smart and several leading software vendors using the Building Smart, the open Building Smart data model. And we are a leading supporter there. We have 5 digital ways of working. We have IDM, which stands for Information Delivery Manuals. That's processors work. We have IFC, already mentioned a couple of times. That's data exchange or data structure. We have BCF, which is quite, well, it's upcoming. It stands for BIM Collaboration Format. So if we have something to say about a BIM, a model, or a workflow, we can do that using Building Collaboration Format. We have the Building Smart Data Dictionary, which is the IFD, which of course Art mentioned and as well. And we have MVD. And I'm not sure if you know what MVD is, but I try to make it a little bit well, clearer with this slide. When we have an IFC file, so a model or a part of a model, as you already mentioned, that can be very big, huge, unworkable. So we came up with the idea of creating model view definitions. And that's a way to look at an IFC. So we don't have to exchange all the information. We can exchange the information that the other party needs to do their job better. That's in the essence, well, what BIM is, that's what I think. Exchanging information with other parties so they can do their job better. That's it. And so we have a facility on the left, a subset or a coordination subset, and those are described already. What I'm doing within Building Smart is we are focusing on creating a model view definition for airports, for owners, for asset managers. And I think that everybody can benefit from that as well. The difference between closed BIM and open BIM is that everybody can work in their own environment in an open BIM approach. So with a closed BIM, we need all kinds of information and sharing data which is unreadable by the software being used, and with open BIM we are able to exchange information on a more structured way. And we call that, the information that we exchange are called aspect models or discipline models. Everybody uses a different model. An MEP engineer is using different model information than an architect, of course. And interoperability is the key word here. And therefore we need open BIM, just to share that information with each other. I took a look at, of course, at the roadmap as well, and I was trying to go through all those international and European standards, but generally did it outstanding. So this is what I find really interesting, that Ireland is looking at all those things that all are already being done outside of your own country. I've got some slides about building smart, because when you are looking at other standards, then open standards are involved in Building Smart. Is the international home of open BIM. And we have a vision that we need to enable full benefits for the built asset industry. So not only for architects or for engineers or for asset management, no, for the total life cycle. We have 3 core values, and that's we are non-for-profit. That's really important. We are open and we are neutral, so we are absolutely agnostic when it comes to software. And we have a couple of goals. We want to define standards, make sure that everybody is using it, and we want to have some compliance there as well. I'll come back to that later. We are formed by chapters, and we have a lot of chapters already. We have the UK and Ireland chapter. And what chapters are the highest in hierarchy in the Building Smart organization. The chapters form the International Council which controls the board, and the board controls the management executive. And on the left you see the Strategic Advisory Council, that is sponsoring. So companies like Trimble or Nemetschek and Autodesk and Kajima from Japan, a big contractor, they are paying really a lot of money to support all these open standards. We're speaking about hundreds, thousands of dollars. And those three core programs you saw on the lower end, that is what drives building smart. So we have the user, the standards, and the compliance program. So we look out what the problems are in the industry. We try to make a standard process out of that, and we are doing some compliance in the end to make sure that everything that is secured or that it's secured in the end. And speaking about that, the compliance part, and you see people as well, and Geraldine, please feel free to join Building Smart there, because we are in the middle of creating Building Smart professional certification. We spoke about it, Ella. It's about individual qualifications. So, as an individual, are you qualified according to Building Smart standards to cooperate in an open BIM environment? And professional certification, and we are not going to do the tertiary education. That's not in our scope at this moment. What we are doing is we are creating at this moment a learning outcome framework that's in process, and we are going to publish that in timely with the launch of the program. And we want to qualify educational institutes or work together with local or national qualification or certification programs. So we are not, as Building Smart, going to the actual individuals. That's up to the industry, but we are going to qualify them. If you Google BIM, then you always see a nice scheme with something in the middle, and it's most of the time round, because everybody's speaking centrally or so. I don't believe. No, there is no such thing as a central model, and it was already said in 2012. It was a very nice study done in the Netherlands at the University of Eindhoven. And there are more disadvantages than advantages working in a, you said a big mama model. I love that. So you have, we don't have a digital twin. We have digital twins of some elements, of some parts, and we can aggregate information. But there is no such thing as a central model. In fact, a central model encourages wrong behavior. Everybody thinks that someone else will solve their problem, or the problem that the one caused that is putting wrong information in. So this is really something to take away today. Another thing is the mandate. So in your recommendation, you say that we need public sector BIM adoption mandate. And I'm following the discussion, what's going on now in the UK. Well, I can say that there are different views about if a mandate can be successful or not. But I think that really BIM needs a strong director. It doesn't always have to be the government. It can come from owners or from contractors as well. So, touching some other mandating countries. In Italy, they are striving in 6 years to have all public works, all public tenders, 100% so in BIM, of course not in BIM. And what they're doing is they seek, so IBMI is the organization that is going to control that in Italy. And we seek each other, so Building Smart and IBMI, and we are looking forward to train the BIM professionals and to help everybody to acquire the interoperable software. And of course, make sure that the definition of the processes are in place there as well. In the Netherlands, Bart already mentioned it, we have the Building Information Council. And that's combining 6 industries: clients, contractors, engineers, utility companies, architects, and suppliers and manufacturers. And they created the BIM Lockpad. That's the organization that is similar to the UK BIM Task Force. They are creating a foundation plan for a BIM gateway in the Netherlands, where they include all the open standards that are at this moment valid in the Netherlands. I've mentioned there COINS was already mentioned, and it's CBNL was mentioned, SFB. So we are going to create a national BIM protocol there. What they did as well is they created a poster, and that poster, you cannot read it, but that poster describes all the BIM uses in a project, and for each project you can pick the different BIM usage, and then they have a legend with the square and the round and the triangle to make sure that everybody understands what they're talking about. And from the poster, I took only the two where standards were mentioned, and that was validation. So validation is a BIM process, which is really, really important. And the other one is exchanging information. So we need to validate information, and we need to exchange information. Of course, via open standards. This is an interesting one as well. You see here, bottom left, lonely and proprietary BIM. And then the typical evolution from infant to adult is going from lonely to social to open and social. And BIM supporters, Dutch organization, worked together with Econex, that's Oracle, and they did a survey to see where the different markets are on this in this evolution. And what you can see is that UK is doing really good. Ireland was not included here, but and the Netherlands were shifted already to the right, so we are becoming at it. And why is that working? Well, I can tell you, it's not because of the mandate. It's because we are Dutch, and yeah, well, no, really, and we always look at it from a financial point of view. Well, most of us do. So, if there is a good business case for BIM, 5 minutes, my computer says more. So if there is a good business case, we can work it out. And there's a real bottom-up approach. It's coming from the market. And to make sure that we use the standards that are working. And not all standards are working, or are in evaluation, or in a grown-up phase as well. So, you don't see Kobe that much. And why Open BIM works is because it's transparent, it's including data throughout the whole life cycle, and you can put product data immediately in the model. And that's so important to be system independent and to have a good, very good communication. There's a lot of organizations or national programs going on at this moment. And what we see in Europe is that we are trying to get all kinds of information, BIM information, supplier information, national dictionaries into one big database, which is the Building Smart Data Dictionary. We are trying to see what the best structure data is, which we can use all over the place. And to give an example, this is nice. In France, they don't have a classification system, but they're still building huge buildings. And they did here, you see here from 1949 up to now, they did an investigation which classification systems were used all over the world. You see them switching and moving and ending, and still they don't have any classification system. So it's not the end of the world. If you don't have it, you can still use open standards, which are already there. But I'll share this slide with you. If you take a look from an owner's perspective, then most of the time people think that one size BIM fits all, but that's not the case. Here you see that the clients and owners are on a different level of maturity than, for instance, architects or contractors. This was the maturity sector analysis of the University of Twente in the Netherlands 2 years ago. And I often explain it using the Dunning-Kruger effect matrix. So in BIM, you have a very steep learning curve. So when you start with BIM, it's very easy to understand. But, well, it's so steep that you think that you know it all. And the further you come in time, the more you understand that there's more to learn and that you feel a little bit stupid. So we have the Mount Stupid. And on Mount Stupid, we think that all we need is Revit. Well, it's not that I'm against that, but it can be anything. But that is especially from a client point of view. But then, after a certain period, you come to the conclusion that that's not always working. But IFC isn't. So it's then Dunning-Kruger called that then you're in the valley of despair, and a lot of owners are that at this moment. But then we take them up to the plateau of sustainability, and if everybody creates the open mindset versus formats, then it's absolutely the key to success. I have 2 more slides. Can I do that, Sarah? Yeah. Oh, actually, there's some animation as well. So, Open BIM is very simple. Dura Vermeer, that's an organization and a big contractor in the Netherlands. They are dealing with 45,000 IFC models a year. And they are exchanging a lot of information. And they, together with 12 other contractors from the Netherlands, they created an information delivery manual, which I call KISS as well, but then keep IFC simple stupid. It's 2 A4s, and what they do here is this. They define every project at the beginning of the project which structure to use, how the file name is, how files are mentioned, what the position is, the orientation. So very basic information. It's an information delivery manual, which is very, very handy. The correct use of entities, the structure, the naming of the entity. So how do we call a door? How do we call a window? They describe it, and it's based, of course, on standards that are already there. We have in IFC a slab, and we have a wall, but you can create a wall with a beam command and then extrude it. But for the software, then it's still a beam. But we need to exchange information when it's a wall. So where are we going? We were speaking on file level, and everybody's exchanging information about file level. We are, with BIM and Open BIM, we are moving towards element level. And the next step will be that we are working on that, that we can exchange information parameter level. So we don't have to change everything, only a parameter, and everybody can contribute to that model. And then I hope that you can be just as happy as I am when it comes to OpenBIM. And this is the end of my presentation. Thank you.
Thank you very much, Rob. That was fascinating, and you brought the whole conversation to a different level, and it's great to see the international work happening. Does anybody have a couple of quick questions for Rob? Okay. I wanted to ask you, you showed an awful lot about the international work going on. Is there one country or one system you would say, okay, that's it, that's what we need to be going towards?
No.
No. So, is it a combination of what everybody's doing?
Well, Scandinavia is everybody thinks that it's happening there, and it's not. So it's cold as well there. So. Well, no. It's therefore what we are doing in Building Smart, and you know that as well, is we try to take the best out of all the developments and to combine it. And, everybody needs to have their own roadmap, you know. You have different infrastructure and a different location and everything different than in other countries. So even in Europe, it's very different from each other. And the domination of some parties are some, for instance, in some areas, contractors are dominating, in other areas, architects, and an architect in Germany is completely different from an architect in Sweden. They have a different role. So, yeah.
That's very interesting. No one size fits all.
No. Yeah.
It's controversially mentioned about, you don't believe in the central model. Tease that out a little bit. Why do you say that? Because that goes against the grain of.
Yeah, I don't believe in a central model. So why don't I believe in a central model? Because everybody has their own knowledge and expertise. And you cannot put everything into one big system where everybody contributes to. Well, technically, it's not possible. That's one. Therefore, I don't believe in it now. Maybe it's the end of the road. It's one big model. But at this moment, not. An architect is defining columns in every room, for instance. So from a visual aspect, but the engineer needs to have one big column to calculate the forces there. And so the architect divides it, and the engineer wants to have one big, you know. And to avoid those kind of discussions, I from the basic don't believe in the central model at this moment.
But maybe not division between, but trying to need visual assets.
Of course, but you don't need all the information as a client that everybody puts in that model. So an MEP engineer has, you know, all that calculations being done, and that's most of the time in his model or her model. And the asset manager don't need all that information. They don't need all the calculations. They need the assets. Flow rate and those kind of things, but not everything.
Sorry. With the central model, I mean, we're all from our own perspective interfacing with a building, okay, or a road, or whatever the asset is ultimately. And we all have our expertise to contribute towards the asset. But in a sense, because the systems that are in place today don't facilitate centralization of the information, shouldn't do away with the source, the central source, because the interaction between and the necessity to interact between the disparate sources contributes to the functioning of the overall asset. So I slightly disagree that I think, I mean, I've been involved in some central model applications with multidisciplinary information, and the different, I mean, we all rely on each other's information in order to produce a better asset, which is what we're all about now. So, in a sense, you know, you're centralising the building smart approach as the central in order to use the disparate systems that use command to bring the information into a way we can communicate that information for the asset, but ultimately I wouldn't discard the central model.
Well, I think Bart gave a very good explanation about linked data and semantic data. And that is not one data, it's a data model. So maybe there is one central data model, so which combines all the aggregated information from the from all the models that you need, especially for your purpose. But I don't believe in one big BIM from a building or road or whatever, where all the information is stored in that one big data model. So it's always an aggregation of different sources.